Hello, welcome everyone. I'm Julie Mellk and I am the Balance Outreach Manager. Welcome to our part 2 with Dr. Mohammad Herzallah of eating behaviors. And today's topic around eating behavior is individualized approach at global scale. So looking how we can reach a wider community and audience, but maintain, of course, a unique approach. We're so happy you're here. And as always with Balance webinars, please utilize the chat throughout and the Q&A. So if you want to drop in the chat right now, perhaps how you heard about this webinar or where you're coming from, please do. I'm also going to introduce alongside Mohammad and myself, Jillian, who is a Balance research coordinator. Hi, Jillian. And just to let you know, the flow of this webinar is actually part webinar and then part panel. So we look to you, our audience, for discussion in the Q&A throughout. We will answer in real time your questions. I'm happy to interrupt Mohammad and let him field some questions along the way, but also perhaps to keep monitoring the questions and put them a little bit more at the end so we can have a full discussion then. Jillian will also be participating in asking Mohammad questions around what he presents today. Hello from Buffalo, New York. We're so glad you're here. Welcome, Alina. It might be cold there. I'm in Princeton, New Jersey, and have been with Balance since April. I'm so happy to be part of this community in the professional network. Many of you probably have spoken with me. If not, you'll have my contact at the end of this, and do feel free to reach out. Oh, welcome from Manchester. Wow, thank you for being here, Sophie. We're so happy you made it across the seas. As I was saying, my contact will be in the slides, but also in the chat at the end, and you're free to reach out to me with any feedback that you have for me and Jillian, Mohammad, and of course, to learn more about Balance. Hi, Stella. You missed yesterday's. Okay, so part 1 was a few weeks back, and I will direct you to where you could find that. Would the webinar be shared since it was recorded? I think you're referring to part 1. We had another webinar go on about fear foods for the month of October. That was really fun too. And I can share with you in just a moment where you can find all of our recordings on our YouTube channel. A brief introduction about Balance Eating Disorder Treatment Center. We are a premier eating disorder treatment center offering boutique, outpatient services. So that is unique to us. And we use and implement, of course, evidence-based practices. I'll talk much more about who we treat in our spectrum of services at the end of our conversation. Our mission at Balance is to empower individuals suffering from eating disorders with the tools and skills necessary to heal their bodies and minds. We do believe that full recovery is possible. We at Balance, as the staff, primarily have a lived experience with recovery, and that comes through in all the work that we do. So today's presenter is Dr. Mohammad Herzallah, a neuroscientist, physician, entrepreneur, and research scientist at Rutgers University, and the founding director of the Palestinian Neuroscience Initiative in Al-Qaeda University, Palestine. Mohammad obtained an MD from Al-Qaeda and a PhD in behavioral and neurosciences, exploring biomarkers for the diagnoses of mental health to digitize and democratize mental health. He received a Young Arab Neuroscientist Award, the TED Fellowship, the Aspen Global Leadership Network Fellowship, and was made one of the 500 most powerful Arabs in the world. Mohammad has been selected for the Lancet Commission for Global Mental Health and featured by Forbes, Science, Nature, and TED. We are so excited to have you here again. Thank you.
Thank you very much, Julie and Jillian. It's a great pleasure to be here again, and thanks for having me. I really look forward to this very electrified discussion, hopefully, basically in terms of seeing how we can take this particular logic and flip it on its head and see how we can make patients' life better and how can we have impact potentially by the huge amount of knowledge that we have accumulated over the past decades, if I may say, that hopefully we could put to better use. So that being said, let me go back here. I think you want to meet like, you want to introduce Jillian as well?
Yes, I would love to. So again, Jillian is here as Balance research coordinator, and she tracks the treatment efficacy or success rate at Balance. She's also a PhD candidate in behavioral and systems neuroscience at Rutgers University. Her research interests lie in the relationship between neurons, behavior, and clinical symptoms. Jillian also has an experience as a substance use counselor and an intake coordinator at Balance, and is currently a teaching assistant and published author. Just a few things going on. Welcome, Jillian.
Hello, everyone. Thank you for coming. It is a pleasure to be here.
Thanks. Take it away, Mohammed.
Absolutely. Thank you, Julie and Jillian, of course. So basically, last time we spoke about this kind of idea that maybe we're not really looking at mental health in the correct lens. And how could we potentially think about mental health differently through basically, again, the aggregation of all of the knowledge that we managed to accumulate over, the multiple layers of inquiry, basically. And I propose that this kind of circuit to communities approach, where we could start from the neural circuit, pass by the behavior, pass by the clinical symptoms, and then actually based on this kind of very wide array of variability, we could get rid of diagnosis, because diagnosis would be domesticating what we're talking about in terms of the clinical experience and in terms of what we can do with the patient and for the patients in this kind of context. And today I'll try to convince you with some evidence, basically. So and please do your best not to be convinced and challenge what I'm saying. And again, I would like to highlight a disclaimer in the very beginning. This is certainly not another theory. I don't really care about being right. I care about being wrong, not right, actually, in this kind of context, because that's what helps. And in a sense, and just to make sure that we are what matters in this kind of context and what really matters to patients in terms of impact and impact on well-being and so on and so forth. So what I'll be doing today is I'll share some experimental findings. Some I participated in personally in publishing or preparing for publication, and the rest are in the making. And of course, this echoes a lot of other findings in other groups. It's not only based on my work, basically about these different layers that govern eating behaviors and what happens in the brain and in behavior and in symptoms and so on and so forth. We'll try to connect the different layers to say, okay, actually, do we not need a diagnosis, and how can this work? And we'll take this one step further and say, how can I use this kind of architecture to inform treatment? And how can I take this treatment and scale it up at the global level? So with that being said, just to kind of revise or recap what we did last time. So we went from the symptom layer, where we talked about, the variability of expression and what that entails in the context of mental health, in the context of well-being, in the context of happiness. And what does that actually mean when we just take this apart and say 0 or 1, patient or non-patient, and we get rid of all of that beautiful variability. And we decided that we want to put everything on the table there, or try to put that on the table. And then the second layer beneath that is basically what kinds of behaviors are we looking at? And here I am trying to quantify what happens in the context of reinforcement learning, for example, what we call feedback-based learning, learning from positive or negative feedback, approaching something, avoiding something, basically having a negative or a positive inherent property of the stimuli that we see, and so on and so forth, and look at it multidimensionally, not in a binarized manner, and not really worry about the mean bound way of thinking about behavior and thinking about patients. So we're moving away from averages in this kind of context. And last but not least is to try to put neuroscience to become a utility. Not just think about it as the the kind of luxury to study these neurons and that set of neurons and this set of molecular markers and so on and so forth, but actually to think of it as something useful that could inform us or inform our decisions regarding particular patients and particular treatments and particular therapy approaches. And how could we connect all of that together, which is what matters. Think of it as who amongst you is familiar with string theory in physics and how people connect to the quantum mechanics realm with the relativity realm, basically, and connect a string in this kind of context. So that's actually, in a sense, that's similar to that. Albeit string theory didn't really prove very efficient in terms of connecting the quantum reality with the celestial, very large object context. But anyways, we'll try here again. Let's see if it works. So basically, and how can we take this and make it talk to existing systems in terms of binary categories? Because after all, a lot of us are clinicians, and a lot of the people who are listening to this are practicing providers. So what can we do? Do we just, do a revolution, occupy APA? It's not that, actually, basically. So I'm not proposing that we start a revolution here in the context of, rejecting the system altogether, because a lot of layers depend on that. You have insurance, you have employers, you have government. A lot of these conventions are based on common understanding of what these things are. And a lot of people don't care about the details, They just care about, is this a patient or a non-patient? So for that purpose, as, again, providers, clinicians, let's think about it. And I speak as a clinician as well in this kind of context. And let me put that hat here. So let's go back here from circuit to behavior to symptom. And let me start replacing some of this with actually circuits I worked on personally, and behaviors I worked with, and symptoms I measured in patients and in animal models of disease. So in this particular regard, what we're talking about is circuit. I'll deviate away from the hypothalamus as the focus of eating behavior, and I'll talk a little bit about another system that I've studied for the past 14 years of my professional career, which is the basal ganglia and dopamine and serotonin and so on and so forth, because it's extremely important. This particular system has been shown to be extremely important for what we call habit formation, for goal-directed behavior and habitual learning in this kind of sense. And if you think about eating behaviors as habits, things that we form and don't need to think too much to practice, then this particular brain system becomes very relevant in this kind of regard. So let's think about the basal ganglia and then try to link that to goal-directed behavior in the context of binge eating and anorexia. Again, symptoms, not disorders, okay? Although the disorders were an underlying condition for us to recruit the patients, but what I want to kind of display here is the variability of the symptoms as opposed to the categories, which is, anorexia versus binge eating. So that being said, there is a very beautiful circuit in the basal ganglia that has a striatum as this input structure for the basal ganglia, which is interconnected with a lot of other structures within the basal ganglia. It receives dopamine from the midbrain in order to modulate, things that are coming from the cortex or input that is coming from the cortex to the striatum, and goes through this kind of convergence system where it just exits the basal ganglia as excitation or inhibition to motor, cognitive, emotional, and even visual circuits from the basal ganglia. So that being said, why should we care about this in the context of eating? Again, it's very simple, because if you think about this particular circuit, it becomes really very relevant for the formation of habits. And again, what is a habit? It's basically the immediate linkage between a stimulus and the response without thinking about the outcome. When you say, I want to put my phone's password, you don't think about the phone password. You just move your fingers in a way that actually puts your phone password in a particular manner. However, if you buy a new phone where the numbers are placed a little bit differently with different distances, you will need to look to get feedback, to get the outcome, in order to know that you press the right buttons. That's actually what a habit is. So that being said, I had the pleasure actually working with colleagues at McGill University to look at the basal ganglia, in particular in part of the basal ganglia that is called the dorsal striatum, to think about how does acetylcholine and glutamate function in the striatum, affect habit formation in the context of maladaptive eating. And this is again in animal models, and patients. And in this particular context, we looked at, again, glutamate and acetylcholine mouse models in this regard. And we use what is called genetic mouse models, and we silence glutamate and acetylcholine, which are very abundant in the striatum. And specifically, we focus on this sub type of neurons that we call interneurons that are like existing within this part of the brain that is called the dorsal striatum, and it connects the different neurons of the striatum together in a sense. So that being said, it was quite interesting to see that when we silenced glutamate, the observed effect was on goal-directed behavior. So if you think about habitual learning and goal-directed behavior, these are complementary to each other. When you are unlocking your phone with a new password, because you're not used to it, you're using goal-directed behavior because you have a goal that will rely on what outcome you get. And then based on that, you start building that habit. So once you get used to it, you stop thinking about the outcome. So that being said, when we silence glutamate, the behavior that was significantly affected on average was the goal-directed behavior system. When we silence acetylcholine and subsequently affected dopamine, which was also reduced in our study, what was affected was habitual learning. But so what happened in terms of measures of binge and anorexia? So for binge, we use something called sucrose binge for mice, and for anorexia, we use something called activity-based anorexia. We put some form of a wheel, like a treadmill for mice. They keep running until they die, basically. And this is actually how we measure anorexia-like behavior in mice in this particular context. So that being said, you can see the linkage between glutamate, goal-directed behavior, and binge eating, and the link between acetylcholine and subsequently dopamine, and habitual learning, and anorexia. But again, like, we are crossing all of the layers here, which is exactly what I proposed in the beginning. But so what? What does that mean? What does that entail? And by the way, this is not what I'm talking about. I'm not telling you that I want to solve the problem by saying, oh, I figured it out. Glutamate, acetylcholine does this particular behavioral modulation, and therefore it happens such as expressed as symptoms in terms of binge and anorexia, because it's not that clean. When I talk about glutamate and acetylcholine dopamine, it's not a 1 or a 0. It's not high dopamine or like high acetylcholine dopamine, low acetylcholine dopamine, or high glutamate, low glutamate, or the interaction of which. It's much more variable. And therefore, what I'm proposing is saying, let's just put that variability on the table and subsequently measure the variability in the goal-directed behavior habitual system. Because again, what was reported in the paper, in any paper, is these beautiful bar graphs with averages. But what we care about is the individual. And what you're looking at in terms of individuals are these kind of horizontal lines. It's not the big, bold, title that we're considering there. And then look at the variability in the expression of symptoms, because again, these are not uniform. What we're reporting here are the averages. And as such, we can get a high, low, high in the context of glutamate, goal-directed behavior, and binge. We could get a high, high, and low in the same context. Many, many permutations of this in this sense. But what does that mean? How can this help a patient? And if I take this and say, glutamate, acetylcholine are important for this particular behavior in the diagnosis of binge eating or in the diagnosis of anorexia, then it, like, in a sense, as if I'm telling people, I figured it out. This is the only variable that explains what happens in these particular disorders, but the reality is not. Look in front of you. Because basically there are people with high levels of acetylcholine, dopamine, and basically moderate levels of goal-directed behavior where their habitual learning is not affected, and they don't have any symptoms. in terms of binge, sucrose binge, or activity-based anorexia. There are individual mice in this particular context. And I can guarantee you'll find a lot of these as well in terms of patients. It's not a binary. And last time we touched upon the point that mental health inherited this from infectious disease in terms of the binary classification, where there is a pathogen or there is the absence of the pathogen. This doesn't work in the context of mental health. And there are a lot of lines of work that support this kind of argument. So the question to ask here, okay, mice, fine, but can we ask a mouse about their symptoms? The answer is no. Maybe you can, I don't know. Basically, it's just something I don't want to think about, to tell you the truth. But basically, that's what happens in patients. We can propose all of the best animal models in the world, but not really approach the patient experience, which is what matters after all, the human well-being based experience. So let's take this to patients with eating disorders. And again, these are diagnosed patients that were tested by the wonderful research group at McGill University, and I think in the Sorbonne in France. So basically, we didn't have measures. Like you can't actually measure glutamate and acetylcholine in patient brains directly as we do with mice, because we did genetic silencing there. And what we looked at is actually the goal direction and the measures of symptoms in this kind of regard. And it was a very clear, again, very clear linkage between goal-directed behavior and binge eating, habitual learning, and anorexia in patients. But you see, I'm not just saying binge eating and let me treat binge eating as an isolated average entity. I'm saying, how does this patient, vary as an individual? Because some of these patients have very good levels of goal-directed behavior. They're okay there, but their problem is anorexia. Some of these individuals have very good habitual learning levels, but their problem is binge eating. So how can we deal with this kind of variability? And I took this a step further, and that's actually the part that I focused on in this particular paper with my colleagues, which is I said, I want to forget about binge and anorexia diagnoses, and I want to take the behavior. If I take goal-directed behavior and habitual learning only, and use fancy machine learning algorithms, can I detect the difference between binge and anorexia, or like anorexia and normal, and binge and normal? And these particular classifiers performed with an accuracy of 85 to 90%. So actually, just based on the behavior, just based on looking at goal-directed behavior and habitual learning metrics, we can speak to the binary system. So that opens another door for us, basically, saying it's not just about the symptom expression. There are many other layers that speak to this particular reality that we'll need to consider and reconsider as we're thinking about these particular disorders and what they mean and what they entail in the context of well-being and how we want to make patients' lives better. So one could argue, so, okay, fine, this particular setup in this particular experimental design, in this particular subject worked for you, but I don't think it works for any other like behavioral or mental disorder or mental ill health, if I may use the jargon that I introduced earlier and in the first talk, because I don't think there is anything that qualifies as a disorder if we think about it again in this kind of context, not to be dismissive, but more of to be inclusive in this kind of regard, but for further discussion down the line. So that being said, can you give me another example on another mental problem or mental ill health issue that actually where this kind of experimental setup worked? And the answer is yes. So basically, again, we'll go back to the circuit behavior symptom architecture, and we'll look at major depressive disorder. And this is another line of work I invested a significant amount of time in order just to try to understand, again, basal ganglia, valence learning, positive and negative feedback learning, and symptom networks in this kind of regard. So basically what we used here was EEG, feedback-based learning, and the Beck Depression Inventory. And without like getting too much into the detail, we look at particular signals from the cortex, particular oscillations, changes in the EEG oscillations per patient. We link the oscillation power to the behavioral performance in the cognitive tasks here, okay, the games. We link that not to being depressed or not being depressed. We link it to what kind of symptom network that person has. And this is using a machine learning algorithm, a machine learning approach called NLP, natural language processing, where you can form what is called a lexical semantic network based on these symptoms in this kind of regard. So that being said, how was this useful? And again, how can we entertain all of this variability in these particular patients? So just to confirm what I started with here, this particular setup managed to reproduce DSM diagnoses with 95% accuracy. Just basically saying, I don't want to use this only, okay? I want to use all of that and see who's a 1, who's a 0. That was very possible. 95% accurate, and this is way higher than what you get with just the clinical assessment. There are tons of studies out there that show you that the validity of clinical assessment in the regular setup is 50 to 60%, and the reliability is between 20 to 30%. So that's a huge problem in the field. But if we just kind of widen the horizon a little bit and include other metrics that would just say, okay, I want to talk to the binary system, but I don't want to utilize it in the way that I manage my patient, but actually look at these different layers of things and deal with each one of them. We'll talk about this in a second. Then we're talking about a very different approach for patient care in this kind of regard, which integrates all of these layers of things. Not only do we reproduce the DSM diagnostics or the binary system, but also we solve another really major problem in the field of depression in particular, because one of the issues that are facing clinicians who treat patients with depression is that almost 70% of patients do not respond to treatment, any kind of treatment. And this is a STAR-D clinical trial for antidepressants and many other trials after that via the NIMH. So basically, what this can do is it can a priori predict response to treatment before you start the patient on a particular treatment modality and make recommendations. Just if you, instead of looking at the symptoms and the binaries, just widen it up actually to include circuit, behavior, and symptoms, not just the binaries. So that being said, we get back where we started. So now we understand what this means in terms of a layered system, in terms of the complex mathematical system in this kind of context, if I want to take it one step further. And that's actually the ultimate feat of this. We need to treat patients as individuals. We don't really need a diagnosis. We can reproduce a diagnosis. Yes, it's possible, in order to talk to insurance companies and in order to talk to employers and so on and so forth. But in order for us to care for patients, diagnoses are bad. And honestly, I know that bad is always relative, but in this kind of context, I think we need to rethink what we're doing in terms of our approach to treat patients in any mental ill health problem, and to reconsider that actually this is not just what floats on the surface. This is not just the tip of the iceberg, which is what we call symptoms. Actually, what I wish we were just we were dealing with symptoms. We're actually most of the time dealing with binaries, with has depression, doesn't have depression, has anorexia, does not have anorexia. Nothing beyond that. And we treat the labels, no more than that. But how can we take this and inform treatment? So in the previous experiments that I described with the McGill group, what was really intriguing is that, let me see, I think I'm missing something here, but yeah. In the previous experiment, when the mice were treated with donepezil or L-DOPA, everything else improved here. But look how actually we assess the issue there. We assess the issue by saying, oh, I give them this treatment, and this treatment modified binge or anorexia, which is not necessarily the right, I think it's not necessarily the most appropriate way to kind of think about how you treat a layered complex system. It's more of saying, here are the layers, here are the problems in these particular layers. I want to develop approaches that could perturb or change things in that layer and measure changes in that particular layer, not go beyond. And then actually layer the treatment, not just layer the diagnostic system, or layer the descriptive system for understanding what this particularly mean. So we could have done many other things, not just the donepezil or L-DOPA treatment. We could have done behavioral training, basically the same kind of behavioral task that we applied in the patients or in the mice. We could have made them play that particular task. And there are tons of approaches out there that they call them digital therapeutics, that basically change particular cognitive domains, if I may call them, or behavioral domains in your ability to see the world. And not only that, but also we could talk about that tip of the iceberg, which is what we call symptom or ideas or ideation or thoughts, as psychotherapists call it, and then do psychotherapy. But we're faced with a problem here. Yes, we can develop this kind of layered system. We can treat problems as they arise per layer and then actually see what happens if the treatment is necessary. And of course, thresholds could be developed based on data as opposed to theorization, basically in this kind of regard. And therefore, so does this mean that every patient or every subject who comes across needs all three of these? The answer is no. And this is actually another thing to kind of consider, is that based on this layered system, we can develop what we call active ingredients. And this is a very new development in the field of mental health and mental health treatments, which is, I don't need everything to treat everything, basically. I need just a set of very important parameters to perturb, to change, in order to know that I can change this particular system. And this is very valid as an analytical approach mathematically. But we need data, we need proper data. And I can tell you, I really searched in the literature to try to find something that does all of these layers of things. I couldn't find. You don't find the full variability. People care about passing the narratives or the stories of how they do things, as opposed to telling you, oh, it was a noisy data set. It's always a noisy data set. Mental health is not a clean story. We need to live with that. We need to learn how to live with that. And then ultimately understand that what hinges on that is actually human well-being, by trying to understand all of these different layers of things and build data-driven, evidence-based models that would allow us to say, here are the selected active ingredients for this individual as opposed to that individual, in order to say, oh, this person needs this treatment, this medication, this kind of digital therapeutic, and this kind of psychotherapy. Or maybe this person only needs the psychotherapy, or that person only needs the digital therapeutic, or that person is an emergency, take them to the ER, basically in this kind of context. Because once we do this, we can scale up. Once we figure out exactly what is possibly digitized, what is possibly gamified in this kind of context, how can we take this and give it to the community? Again, I'm talking units across different layers until we get to the full community. Not treat the community as a whole, as a body. It's the community is a group of individuals, and each individual is unique. Each individual is their own story, is their own concatenation or basically layers of these particular metrics that we're trying to introduce here. And I would like to cite this upcoming paper that my colleagues and I actually put together. It's coming up in the first issue of Nature Mental Health by January 2023, hopefully. And it carries a lot of these ideas that I spoke about, from neural circuits to communities, an integrative, multidisciplinary roadmap for global mental health in this kind of sense. And let's put mental well-being and individual mental well-being as basically our direction, as our compass. And we really do not need diagnoses to treat our patients. We need diagnoses to speak to, again, insurance and other regulatory systems and other systemized top-down approaches that help us communicate. But when it comes to the patients, we can do a much better job. Thank you very much. Back to you, Jillian and Julie.
Go ahead, Jillian.
All right. Well, thank you, Mohammed. That I always enjoy listening to you talk. I always learn something new. So if anyone has any questions for Mohammed, please put it in the chat. Julie will read it aloud, and Mohammed will go ahead and answer it. I can start everyone off, though, first with a comment, and then I'll push back on one thing. So my first comment is just because when I first heard Mohammed talk about this, I was really blown away, because typically, as we were saying, I mean, what I found in the literature is a 30% inter-rater reliability. So if you give multiple therapists the same patient, only 30% will come up with the same diagnostic, right? And the same thing for treatment. I think Mohammed touched on this. It was about 30%, right?
Yep.
For treatment response.
Yep.
So it really blew me away, because I'm like, for it to jump with this tool to 95% is huge. It's absolutely groundbreaking. So that's just my first comment on that. Yeah. So also the other part of that was, I think it's really important that Mohammed has kind of come up with a new definition of these diagnostics, right? And because he has come up with this new definition, we can use that definition to improve diagnostics and improve treatment outcomes. So my question is, how does your definition of like eating disorders and MDD differ from that of the DSM? And why does that like kind of improve?
That's a great question, Jillian. Yeah, let's challenge this, because let's think of this as a philosophical school of Stoics, Stoicism. Let's try to prove ourselves wrong, not right, so that ultimately we could help patients. So, I mean, basically, it's the same ingredients. What I'm saying here is, instead of saying I want to get to the binary of calling this person a patient or a non-patient, I say no. Let's just take every possible chief complaint, again speaking clinical concepts here, and then put them all on the table, and then actually go one layer beneath that and tell me what are the quantifiable, supposedly objective measures that defines this particular individual, and put them on the table, and then actually take any kind of measures that define what is called biological signals, and then put them on the table, and then put all of that in front of me, instead of saying, oh, I just want to talk to the patient, assess the symptoms. So in a sense, I am using DSM symptoms, actually. I am using psychotherapy symptoms, but with the full package, and the full package being interconnected in a sense, using the logic of graph and network theories and the logic of mathematical complex systems to go ahead and say, how to make sense of that. Do I really need to call somebody a 1 or a 0? Does this help? And does this help not only in this particular disorder, but in other disorders? Because we know how much overlap there is between diagnoses in DSM. So do we really need them? Do I need a diagnosis to treat a patient? Or do I know who I am dealing with these particular numbers or metrics across these layers, to be able to address each one of these particular deviations? I don't want to call them problems. These are deviations. There is nothing called normal, by the way. So I hope this answers, Jillian.
Yeah, it definitely does. Thank you for that. Again, if anyone has any questions, please put it in the Q&A. We'll get to them. So my following question is kind of a practical implementation question, right? So I know we ideally want to put someone through an fMRI, we want to put them through an EEG and see how their circuit looks. The problem is, right, is that these small psychotherapy practices or dietitians in small practices, they don't have access to neuroscience tools, nor do they necessarily have the training, right? Unless you're in a hospital, then, right, you would have access potentially. So is there a way that we could implement this not using the circuits, or is there a neuropsychological assessment that we can use to replace, or, kind of roughly replace the circuits?
Well, the answer is absolutely yes. So let me give you an example. In And actually, it always helps to think about this in the context of other practices of medicine, not just psychiatry. So basically, let's think of this as oncology. When somebody goes to the doctor and tells them, I get basically a lot of hot flashes at night, they start with a CBC, with a complete blood count. They don't send them for a differential and to see a heme-oncologist, in this kind of context. So basically what we're talking about in this particular regard is maybe you can start with a 5-minute game instead of saying do the full thing. And then based on how, but actually there is a prerequisite for this. The prerequisite is big data. We need to collect enough data from enough subjects, individuals, to define what this system entails and what this defines in the context of the within individual, not the averages, not the groups. So after proper data collection, and we're talking about like a sizable data set, maybe this is actually something that we could start as a collective collaborative effort here. Once this is in place, we then would be able to know if I take this particular pattern with that particular pattern, can I autocomplete without measuring EEG or without measuring the symptom? And that's basically what we did partially with these very simple computer games, where we just take the game, nothing else. And we could estimate the different symptoms with the 95% accuracy and estimate response to treatment with 95% accuracy in depression. So basically, we don't measure EEG for that. We infer EEG based on our understanding of that big data. But again, this has to be big data, and this has to be properly assessed in the context of artificial intelligence, not just any classifier, any kind of right off the hook, basically, application of these mathematical packages. So,
yeah, definitely answers my question. Again, and if anyone has any questions, please put it in the Q&A. Mohammad would be happy to answer it. So I guess my next question would be, right, we talked about circuits, which is neural activity, right? We talked about the behavior and then the symptoms. So you kind of put psychotherapy with the symptoms, right? You put behavioral training with the behavior, which is kind of psychotherapy as well. Where does the medication come in? Can you speak to the medication part as well?
Excellent question. So behavioral training is not necessarily exactly like the psychotherapy. It's more of like this kind of gamified digital therapeutic, which is an emerging field these days. So it's literally playing games, in a sense. But medications, I would always like to think about it as a chemical perturbation of the system. And therefore, it has to be at the circuit level or even the molecular level, which is beneath the circuit level in this kind of regard. And therefore, I would say that actually a lot of evidence speaks to this, Jillian. So when you treat a patient with depression or anxiety, you don't see the effects immediately, right?
Right.
It takes 4 to 6 weeks in a patient with depression for like an SSRI to work. Why does that happen? Because it has to traverse all of the different layers. When you put an SSRI in the tissue, you see a spike in serotonin, but apparently it's not the only thing that is happening there. So it has to traverse that to the behavioral layer and then to the symptom layer, if the patient responds. Okay, so that's how it works, and therefore that there could be things that could be done in different directions. However, I need to mention something. It was done by one of my some research that was done by one of my mentors at Oxford, Catherine Harmer, who actually proposed that maybe there should be could be a collision between bottom up and top down treatments. Right. So when you apply medication and psychotherapy, you could actually kind of cause a collision and cause these treatments to cancel each other out actually. So that's a possibility that we need to always be paying attention to. But if we adopt this kind of foolproof approach where we measure layered level indicators, what I proposed earlier, of response to treatment, we could potentially avoid that.
Okay. Yeah, you just answered my follow-up question. How can we avoid a collision, right?
Oh, sorry.
That's okay. Right.
But actually, another I would like to supplement that with data. Let's not theorize.
Right.
Let's be evidence-based. Actually, it's quite interesting because I think evidence-based medicine was invented almost 3,000 years ago in an area that is currently part of Turkey. And the philosopher who actually came up with this is called Monodoros of Nicomedia. And it took us 2,000 years to realize he was right. Because 150 years ago, people were developing theories about how the brain works or how the body works, and they would follow the theories even if the patient lost their lives. So I think we, as a human race, need to auto-learn, basically in this kind of context, which is a very difficult proposal to make, but it's just.
Right. So if we get something wrong in this model, we should take that as information, right, and improve the model.
Absolutely, absolutely. This model is based on information. It has no ego to it. It's just relying on what you feed it, basically, in this kind of sense. And that actually uses the best of the worlds in the context of machine learning and self-correction, and what we call intelligence, which is, I mean, a lot of the people who work in the field know that machine learning is not learning and artificial intelligence is not intelligence. So don't be fooled by by the terms, but basically it's more of like, these are really useful tools that we could utilize.
Right. So for us to start implementing this, do we need the games? Do we need the big data? Or how can dietitians and therapists implement this today with their clients without having the EEG or the big data?
So thank you for asking this question, and I like your bias toward action, which is fantastic all the time. So basically, it's yes, you can. The answer is always yes, you can. I mean, I'll be more than happy to help anybody who wants to start implementing the different layers of things. Basically, especially to have access to these gamified solutions, as well as the versatile expression of symptoms, because I already built these models and they exist. And actually, we're trying to build this into a utilizable tool as well in the coming couple of months. So anybody who's interested, feel free to reach out. I'll be more than happy to help you with things I currently have, or I direct you at least to resources that you can use immediately. For the circuit, it's a little bit trickier, because it would require additional types of trainings, but we're still working on that, because there are a lot of really very nice tools out there that could give you an EEG of like 2 or 3 lead EEG based on a headband, or like basically all of these wearable devices that people put on in terms of measuring skin conductance or measuring heart rate. By the way, heart rate is an extremely important and beautiful signal that we could actually use in mental health. So that being said, there are solutions. I would say not completely there, but could actually significantly help people to, or providers and clinicians, to get a better picture about their patients. And by the way, it takes 5 minutes to play one of these games, no more. So it's not costing you time. It's not costing your patient time. Actually, it's much better for your patient, because you can have them do that before they arrive in the clinic.
Right. So how could we measure heart rate and then have that in
in a meaningful kind of like context? Yeah. Well, actually, there are a lot of things that we could look at in the context of heart rate. So it's a whole full field in cognitive neuroscience that is called heart rate variability studies. And you can actually kind of see how basically these particular accelerations and decelerations and changes in the frequencies of how heart rate happens could basically predict levels of stress, predict levels of anxiety when properly accumulated, predict levels of mood fluctuations as well. There are studies out there that you could look at, and you could extract a lot of other metrics related to EKG from these wearable devices, and also a lot of studies were done in terms of how does that relate to particular brain signals in this regard. But again, these are inference, like indirect measures that we could use to predict things, but not necessarily gauging the actual signal that we're trying to measure here. But it's super helpful.
Okay.
I have a little bit of a follow-up question to that. If this is implemented and providers are measuring other forms of data, then what do you forecast or predict for provider adaptation with how they're treating individuals, what the rapport would be like, what do you see in the skill set that would be needed?
I mean, basically, excellent question. Absolutely. Because, I mean, first of all, awareness, like providers need to know that all of these things exist out there. And potentially it's part of their responsibility and our responsibility as a community of clinicians and scientists to work together to make them aware that these things exist. And they need to be on the lookout. It's not just this is how things are done, and I don't want to like look beyond that, because that's the well-being of the patients. That's actually their practice in this kind of context. So that's extremely important as part of a responsibility of a provider or clinician to think proactively in this sense. So that's actually that's issue number one. I would like to start with it again as a clinician myself, and as a clinician who saw a lot of patients. It's on us as clinicians to do to make this happen. In terms of the other skill sets there, Julie, it's not that different from any kind of computerized intake systems. So basically, there will be assignments for the behavioral games. There will be assignments for the the kind of different trees of symptoms. There would be, you send a request if the patient needs an EEG or an fMRI or something like this, in a particular context. So it's not that different from dealing with any current computerized system for intake. So I would say in our today world, just being able to use a tablet or a computer, no more than that.
Right.
But in terms of interpretation, it has to, like, again, it's basically this awareness of these different layers, how to think about things in this particular context, and how to think about the variability. And that's where machine learning and AI becomes really relevant, because that's what could do the matching for us. So, this patient has this particular issue, and then therefore I match them with this particular optimized treatment. Do you agree as a clinician? So by having awareness, by having that particular background, by training ourselves in this kind of layered manner, we can think properly about the patient as an individual package, as opposed to part of a group.
So it's really on us to be aware of, right, the tools that are out there, collaborate with scientists, which I think Mohammad and I talk about a lot, is that the communication between science and clinicians just isn't always there. So I think everyone, right, improving that communication is a key component to making this work more globally, right? So thanks for that. So there's only 6 minutes left. If anyone has a last minute question, please put in the Q&A. If not, Julie is going to go over our programs here at Balance and all that good stuff.
And if I may end with one remark here, thank you again, Jillian and Julie. Anybody who wants to reach out, please reach out to Julie, and she can connect you guys to me. So I'll be more than happy to talk at any time about any of these details.
Thanks, Mohammad. So I wanted to speak a minute about who we are at Balance, what we do, our approach, our philosophy. We treat the spectrum of eating disorders through outpatient services. That includes anorexia, bulimia, binge eating disorder, compulsive overeating, and other disordered eating behaviors or body image issues. We have individual nutrition counseling, outpatient groups. We have a 15-hour-a-week evening intensive program. We have a 30-hour-a-week day program. Our philosophy is an integrative treatment model, not limited to these, but we include CBT, DBT, creative art therapies, yoga, individual, group, and family therapy, meal support, and as I mentioned, nutrition counseling for everyone that is in program with us or is working solely with a dietitian, an eating disorders specified dietitian. If you don't mind moving, Mohammad, to the next slide. Thank you. Again, a recap on our programs. If you would like to learn more about these, when to refer someone to Balance, please by all means reach out to me, Julie M, at Balance with a DTX That's my email, and I'm happy to schedule a brief call with you. If you have any questions for Mohammad, I will connect you with him directly. We do offer all of our services virtually and some in person as well, our day and our evening program. Just a couple points on when to refer. This is a question I get asked quite a bit when your client is unable to put the work into practice without monitored meals. You're noticing that behaviors are not decreasing, such as binging, extreme food aversion, and to reduce the relapse, of course, after residential. Step down shows that into a program of our sorts shows that recovery rates are far greater. If you'd like to refer a client to speak to an intake coordinator, we offer free 20-minute consultations. That's at this number here, 212-645-9603. I do want to mention that we are offering in mid-December through nearly the end of January, a 12-day winter intensive program. So if you'd like to learn more about that, please reach out to me and I can elaborate. I want to thank everyone for attending today, but a huge special thanks to Mohammad and Jillian. This has been incredibly insightful, very exciting for me to learn. I hope everyone else thought so as well. We do have quite a few comments saying this is fantastic. Thank you. I did put in the chat as well our YouTube channel where you can go and watch part 2. I'll send that out as a recap. But also on our YouTube channel, besides this webinar and the part 1, webinar that you can watch with Mohammad, it are all of our webinars. So please take advantage of the continuing education there. Some are professional and some are more client facing. Perhaps one of your clients would benefit from those conversations. Have a great weekend, everyone.